Broadcast is now starting. All attendees are in listen-only mode.
Good afternoon, everyone. It is 12:02 and a lot of people are joining, so we're going to start now. My name is Anna Zylik. I am with ICF, and we are the vendor working on behalf of Mass Save and Energize Connecticut to bring these Passive House trainings to all of you. So thanks for joining us today for this Passive House and Embodied Carbon webinar. Just to let you know, we are recording this training and we will make this available afterwards. These trainings are at no cost thanks to the sponsors of Energize Connecticut and Mass Save. And these trainings are also in partnership with Connecticut Passive House and Passive House Mass. A quick reminder that both the Mass Save and Energize Connecticut programs are offering a 50% cost reimbursement for professionals pursuing FIAS or fee accreditation trainings. So this includes the cost of the training and the exam, and once you become certified, we'll work with you to process the 50% cost reimbursement. Our emails will be on the last slide, so if you do have any questions about that, please reach out. And with that, I will pass it over to Keegan, who is also with ICF, to talk about the Massachusetts and Connecticut Passive House building incentives.
Thanks, Anna. Yeah, and Michael, if you want to jump to the next slide, the next one. Welcome everyone and thanks for joining. So in addition to these great training offerings through Energize Connecticut at Mass Save, as well as the accreditation reimbursements that Anna mentioned, both Energize Connecticut and Mass Save both offer an incentive path for multifamily buildings that choose to pursue Passive House certification. The incentive paths include incentives for feasibility studies as well as certification costs. So if you're interested in learning more, we encourage you to visit the Energize Connecticut or Mass Save website for more information. With that, I will pass it off to our presenters today, Michael and Christina.
Okay, thanks. Was there anything else you wanted to say about these slides, or is this sufficient?
No, I think we're good. Yeah, it's all you.
Okay. All right, very good. I'll let this linger for just a second because these incentives, I have to say, these incentives have been incredible. They've really helped people who were maybe not ready to take the leap and they've covered a lot of the incremental soft cost. It's been a great help to us as practitioners. So anyway, I'll introduce myself. My name is Michael Hindle, and I am the owner of Passive to Positive. I founded the company in 2010 and did this if you can see my cursor, this first little single family residence up here was a Living Building Challenge project here in Maryland, where I live. And ever since, we've been pushing forward with deep energy retrofits, new construction, single multifamily, institutional. We're a small company. It's and I'm here with Christina Osman, and it's between us and a couple other people working with us. But we've managed to attract some really wonderful projects, and we feel very privileged to have done so. Christina, would you like to introduce yourself?
Hi everyone. So I'm originally from Germany, as you probably can tell from my accent, and really growing up in Germany instilled like a deep appreciation for environmental stewardship in me. And so that's how Michael and I connected on this deeper level of thinking about, the earth and how to preserve it for future generations. And so I'm really happy that I'm working with him and, that we are trying to make a positive impact on the planet.
So, we're going to just start by saying a little bit, well, I guess I should say the title is at the bottom of the slide, the low carbon imperative. And we'll probably go even a little further than that. But just to set the tone, this is going to be just a brief description of how we see the world. basically, from my perspective, it's undeniable that profligate consumption, cheap and available fossil fuels, refrigerants, all of these things have made us kind of lazy from a design perspective and have led us to basically use what we can. And so we make, consume, consume. And it has made our culture completely unsustainable. What's more, this entire system that is completely unsustainable is extractive and linear. In other words, it pulls resources out, uses them, and the throughputs are waste, and it is a one-way trip. And it is a one-way trip for the resources. It is a one-way trip for assets that we generate, such as factories. And it is a one-way trip for community. And so as we abandon any asset, the moment we get a cheaper labor source overseas, we will abandon the factory and abandon the human beings. So as soon as a cheaper source is found, we move on. This kind of mindset is incredibly systemic, and it defines essentially everything we do. The last part of this one-way trip is externalizing all of the wastes. And so we basically pull resources, create things, and then dump our trash on less fortunate people, or in the Pacific Ocean, for example. So we would like to articulate another way of looking at things. But first, we have to acknowledge that one of the most significant forms of waste is carbon dioxide. And it has led to, as we all know, this year and last year and prior years, devastating wildfires, droughts, and flooding. And while I know we all know this, and I don't need to preach to this choir, there is these graphs on the right and the image from Oregon on the left show us just some of the impact. But the three charts on the right show the number of days over 100 degrees. And you can see that under 10 days over 100 degrees in the recent past was essentially the whole country. If we manage to get our act together and create a low emission scenario, the center of the country, most of the breadbasket, is experiencing for 30 to 60 days over 100 degrees a year. 1 degree average temperature rise results in 10% lower agricultural yields, not to mention the extractive forms of agriculture, the destruction of the soil, the loss of topsoil. We've lost 50% of our topsoil in the last 150 years globally. If we keep going this way, in the bottom image, the whole center of the country is at 90 to 110 degrees over 100, days over 100 degrees a year. There is no food in this scenario. There is no economic investment that is safe. There is no legal system that can deal with the level of injustice that will arise. In other words, we are talking about imperative from the deepest emotional, moral core we can. Another way of saying this is that we have already overshot the carrying capacity of the planet. There are lots of ways to predict this and graph this, but basically since 1972, with the limits of growth from the Club of Rome, there are plenty of models that predict that here in the middle image, we are at 2019, the services per capita and the population is still rising, but so is pollution, and you can see the resources, the blue line in the center, just dropping precipitously. And at a certain point, we extract so many resources that our food per capita, our industrial output, everything collapses and population collapses. So this is where we already are. The terrifying thing is that if we don't correct course soon, our overshoot can actually degrade regenerative systems that are the default mechanism of the planet to the point where we erode their capacity to rebuild. And if we do that, it would take hundreds, probably thousands, maybe tens of thousands of years for that system to recover and oscillate back into what we now know as the carrying capacity. There's no big bang that shows us that this is happening. It's already happening. In fact, we crossed that threshold in 1980 when I was 10 years old. We've already overshot the capacity of the planet since 1980 by 20%. And for everyone to live the way we live in North America and Western Europe, you would need 3 planets. And in order to meet projected population rise and material growth of the next 40 years that is currently projected, we would require 6 to 12 planets. And all the techno-optimism in the world will not compensate for the material limits of this closed loop system. That's a whole other conversation that we could have with Elon Musk and others. But the idea that you can transcend the material limits of a closed loop system like a planet with an atmosphere is just crazy. So we have one atmosphere, one biosphere, one set of physical resources, and we, each of us here today, only has one life to do something about it. Christina, would you like to talk about this?
Sure. I mean, this sounds all doom and gloom. Obviously, you know, we want to look at it also from like an optimistic standpoint, of course. And sustainability really means that meeting present needs without impairing future generations' ability to thrive. But that's not good enough. You know, we've done quite a bit of damage. And so really what we need to look at is like a regenerative way of being. And that means it has to take into account repairing and regenerating damaged systems. So, you know, like looking at it from a really holistic standpoint.
This is a graphic that we drew on from other sources, but basically everything humans have ever done is below the center line. And everything, therefore, is defined as a degenerating system, that one-way trip I described earlier. In order to actually save ourselves and the planet, we have to get above this line. So green building standards have been incrementally less bad for the environment. Sustainable would be 100% less bad, but it's still not good. In order to do actual good, you have to create a regenerative cycle, a virtuous cycle of repairing the damage. A lot of that is going to happen by using renewable resources for everything we can. And so the left green side of this chart shows that you can create renewable resources within the biosphere to serve most of our needs. Anything we cannot use in that, we cannot create out of renewable resources must be brought into a circular economy of reuse, recycling, and repairing. So, Christina?
Yep. So we want to be looking at a healing system, and really like the main focus is conservation first. We want to do no harm and making sure that we reuse and restore the existing fabric, everything that's there already. We want to, you know, reuse and restore, and we want to repair, you know, like the common resources that we have, you know, that's available to us. And it cannot happen without looking at people, at culture. I mean, you know, see that I'm transplanted into a different culture, and so you know, are very many other people, and you know, especially with climate change maybe challenging, you know, the cultures of different generations. I think it could have total impact. So we need to be aware of that.
And we're all part of building design teams. You know, we are the system, and we have to be the change. So when it comes to carbon, that's the topic of today's presentation. First of all, I'd like to say that I don't have a definition slide, but basically we're going to be talking primarily in terms of CO2e, which is to say carbon dioxide equivalent. So there are any number of gases, as we all know, that can cause climate change, and carbon dioxide is just one of them, but it's also the most common. So basically we do conversions, we don't do, but professionals who do this analysis will do a conversion of, say, methane to carbon, or a refrigerant to carbon dioxide. And I just messed up myself. Carbon and carbon dioxide are two different things. Obviously there is carbon in carbon dioxide, which is in the atmosphere. So when we say carbon, we're being a little bit lazy. We should really say carbon dioxide equivalent. So that usually comes in the form of kilograms per meters cubed, or something to that effect. And it changes. Different people will report it in different ways. So we're going to be speaking about carbon as really, what it really means is carbon dioxide equivalent, global warming potential. Now, one thing that's really important, I bet a bunch of people have already seen this slide or have seen this kind of chart. Jacob Recusen, Ace McCarlton, and Christopher Magwood have presented on this at NESE, absolutely fantastic set of presentations. In any case, the time value of carbon is something that we need to understand quickly and address quickly. The yellow bars on this chart, the yellow vertical bars represent embodied carbon, upfront emissions associated with building buildings. The gray bars represent operational energy over time, and it's cumulative. But we now know from the scientists studying this that we have an earlier tipping point than maybe we ever imagined into runaway climate change. So if you look at, say, 2030, which is the Intergovernmental Panel on Climate Change target for major reductions, right? The embodied carbon is still the majority of the total carbon emitted by a building. So if we build now with the carbon intensive materials, we are doing a grave disservice to the climate, even if we're zero energy. There are other charts that we could show you that show a zero energy building with a greater carbon footprint because it uses carbon intensive materials. This is from Builders from Climate Action. This shows the same building, basically using conventional uses. You could get the red image with massive levels of carbon emissions, or you could be slightly better and do incrementally better and have only 90 kilograms of CO2 equivalent per meter squared. Or you can do more aggressive conventional use and actually start to get negative, reduce carbon emissions to the negative. And if you use natural renewable materials, you can actually start locking up, drawing down, locking up, and storing carbon in your building. And so they did a lot of work on any number of different methods you could use to create a deeply carbon negative, which is to say a carbon storing building. And this is being done. We're trying to do it wherever we can, but there are examples such as this that have been fully analyzed, which is a modular straw panel wall type that was used to build a school in England. And you can see it sequestered 376 metric tons of carbon dioxide gas equivalent by building with this renewable material. They're also beautiful buildings and healthy buildings. So we have to choose materials for their regenerative impact. And there are lots now, and there are also materials such as concrete alternatives, which use a lot less carbon. So even if the material itself cannot be regenerative, it can dramatically reduce the harm you do so that your renewable materials can tip the balance towards a climate positive impact. So we're going to talk about a couple of projects here. The one on the left is North Avenue, workforce housing here in Baltimore. We're working on this with Tim McDonald and Onion Flats Architects. And this is 7 different row homes with, I think, 18 units. It's affordable housing with first floor retail. And it was initially planned to be a tear down. And Christina is going to talk about this balance between tearing down or building new in a moment. The picture on the right is of a 1923 synagogue. It's absolutely gorgeous inside and out. It's been seriously degraded, unfortunately. This is in Pittsburgh. And we are deep energy retrofitting the adjacent Hebrew school and as a second phase, this synagogue into a community center. So it'll have 45 affordable housing units and the 10,000 square foot footprint community space, which will be worship space, performance space, etc. So I will let Christina start now talking about workforce housing.
Yes, so you see here a nice rendering of what it will look like once it's like all completed. Basically, as Michael mentioned, there's an existing structure that's there. currently. So 7 existing row homes in varying degree of, state of dilapidation. And but we thought it was really important to figure out if we can save some of the building structure and what the impacts are. I mean, obviously our main goal is to do passive house. And with passive house, oftentimes, like the focus is so much on operational energy, right? That's the main goal. I mean, with that goal comes also, like better indoor air quality, resiliency, human comfort, just being in the space is much more nice. And then also, from acoustical values, it's so much quieter, especially in a busy, bungling street like here in Baltimore. And so, those considerations are all on one side, but on the other side, you want to also look at, if you put passive house envelopes on projects, oftentimes that is achieved through high embodied carbon impact in terms of like adding so many materials, a lot of like foam-based materials. And so in our practice, we're really trying to kind of figure out, like a responsible way of achieving passive house.
Christina, so before you get into the chart,
yes.
I wonder if I could quickly return to my.
Yes, of course.
These charts are, we have several, and they're maybe not the most compelling part of the presentation, so we're not going to spend too much time on them, but it's important to see that there are different phases in operation of the building from, well, not from of the building, but the material. So on the left-hand side, your first phase is the extraction of the resources, the processing and manufacture and transport of the resources. The second phase is construction. The third phase actually includes maintenance and operation.
And I also included demolition because I think that needs to be considered as well. So that's something that I added because I think it's important. Like if you have a site that has already structures on your lot, I mean, you can't just ignore that. So you have a responsibility, and you should, in my opinion, take a carbon penalty if you just tear them down and start from scratch. So that's why we added that specific piece here. It's minimal, but yeah.
So can you describe to us what we're looking at here in this?
Yes, of course. So basically, I mean, so you're looking at the orange color, which is representing the masonry. And you also see that we have like a baseline here at 0, and then we have some negative and positive values. And so basically, the basis of design represents, it shows like the big amount of masonry that's already there, and, comparatively speaking to like the blue amount of the wall, which is the backup wall to make our structure now passive house. So in this case, by combining the existing structure with the additional new construction, we are achieving an R value of R26. And then we were comparing this with 2 other options here. And so the first option would be to kind of pull from like some of the other wall sections or wall assemblies that will be on the project. And so we wanted to just be realistic about what we would be building. And so that's like one of the assemblies that we studied. And so in this case, it would have also a masonry look because you would be wanting to have that same kind of feel. But
and indeed, Christina, if I could just interject,
sure.
The first plan for this project was to tear down the existing buildings and build with the very assembly you're describing here.
Exactly. So that would be the one that we would be, considering. And so, but it would be less masonry than, the existing structure. The existing structure is 2x masonry versus like a new assembly. It would just be like basically a rain screen cladding of masonry. So you can see there's a less impact, of course. And then you see, if you look very closely, there's like a small sliver of polyiso that I also pulled out from the new construction. And so that's the a difference between option 1 and 2. And basically, we think that's important to reuse or reclaimed materials. So in this case, if you use reclaimed polyiso, your footprint shrinks down by a tad in this specific situation. And so when you look at the total amounts of energy, and embodied carbon equivalent, you see that the choice of basis of design makes total sense in this case. That we are adding a little bit more to create our R26 wall. We could achieve a R30 wall but the impact would be so much higher in terms of embodied carbon. And then I also studied, what that would mean in terms of source energy. And so the difference here is like, going from that R26 wall to the R30 wall would probably be like a small refrigerator for these 3 row homes that we studied. And for the whole project, probably 2 small, tiny refrigerators, running for a year. So just that gives you like a perspective of the impact. And so really that's why we think it's so important to think about embodied carbon also in this equation, because there we have some really big decisions to make.
So our big move here was to say, okay, we're going to try to not use any foam insulation. And because of any number of different reasons, it was preferred to remain with foam. But you can see that the polyiso foam is relatively small compared to the cladding. Now, so getting rid of that by using reclaimed foam is a good thing, and we believe in doing that, and we're doing it on virtually all of our projects right now. So you only have the transportation carbon footprint for that foam. But the real lesson, one of the other real lessons here is, oh my gosh, brick is a nightmare. So if you're looking at the carbon footprint of this wall, retrofitting interior, using as much as you can of the existing fabric is really important.
And I also wanted to mention that, this was fairly conservative because, this is like taking in, was all modeled in Athena, but, taking into account today's construction methods. And, at the time when these row homes were constructed, it probably was the energy, much more energy intensive to create these bricks. So it might be that, that my negative would be even deeper, like realistically.
Correct me if I'm wrong, Christina, but we're not actually saying we're claiming credit.
No, we're not claiming credit. I just want to basically give you a perspective of what it means in terms of, like having impact. Yeah.
How much carbon is already emitted for that material?
And we have the responsibility to really, do something with it. And if we extend the life of it, that makes total sense. So that's basically our message. Yeah. So yeah, for the next study that we did, so that's the rear walls. And the rear walls, they are not as, not as sexy in a way, they are like just, they're not the face of the project. And so there we have a combination of existing structure that we're saving, also new construction as well. And so in the basis of design that is combined, you see there are still some masonry and significant amount of masonry that we were able to integrate, but also a significant amount of new construction as well. And then for option 1 and 2, we were looking at what it would mean if we took out the masonry and just replaced with all that new construction type that we would be doing anyways, and just making it easy for ourselves. And here you see the polyiso actually has a much bigger impact in terms of making a difference, right? So you see that, like especially when you look at the totals, like the option 1 and option 2, which is just the difference there is just that we are using conventional polyiso in the assumption on option 1, and then reclaimed polyiso in option 2, like how big of a difference you can see there. And I also wanted to mention, my passion is really in looking at Living Building Challenge, healthy materials, the clear labels, the red list. And so in this case, there are a few options for red list-free polyiso that you could use. So if you needed to include it in your project, you could, and get a Living Building Challenge project certified. So these would be halogen-free polyiso products. But still, it would be making more sense to use used materials if you can. That's definitely a message I wanted to share. Yes, of course.
Because I share this passion, if you will. Polyiso, polystyrenes, all of these foams have impacts well beyond carbon equivalent. And so they are endocrine disruptors, they are neurotoxins, they are carcinogens. And every community that lives in proximity to manufacturing facilities, is affected, right? And these materials are released into the environment over time, certainly with the degradation of this material. All the reclaimed polyiso we're talking about is coming off of some other roof somewhere, and we're repurposing it. We're locking it up for another, hopefully, 100 years so that those negative impacts will not be felt by nature. So that is the argument for choosing the reclaimed polyiso.
Right. Social
if we
justice
did not have a
is
demand for it in the first place, we'd be better off.
Yeah, of course, but yeah, definitely a good way to go. And then the other thing that we studied was a foam-free option. So using a bigger stud wall. So instead of 2x6, we are proposing 2x8 stud walls there, and there's no continuous insulation. And so just for reference, the basis of design, we were looking at an R30 wall and an R13.5 wall. So the existing wall has a significantly less robust R value. And then for option 1 and 2, we were looking at R30, and then the foam-free option for option 3 would be R22.5. So, looking at the range of different solutions here, we also want to look at what that means in terms of operational carbon. For option 1 and 2, we were able to save a little under 1% of the total source energy. And then for option 3, we were actually adding a little bit of source energy, a little bit less than also 1%. But in the whole realm of, looking at this from a really big picture view and holistic view, we think that looking at embodied carbon in general makes total sense here, and should be a decision-making factor.
The last thing that we wanted to say about this slide is that maybe Christina first, you could describe what is included in the blue bar, and as Christina mentioned, we're using Athena. Which is not the most precise tool, but she'll describe what's in the bar, but what we want to talk about also, but we don't have an analysis for because we couldn't find environmental product declaration forms that included this information. But a significant part of this blue bar is the studs, correct, Christina?
Yes. Yeah, it's basically everything besides, what is called out specifically. So everything that's not brick or polyiso.
So studs, drywall, screws.
Exactly, everything.
Sheathing. Now, if you use...
Michael, Christina.
Yes.
We have one clarifying question. I just wanted to jump in.
Sure.
A difference in the chart between new and brick. Does that mean we're counting existing brick as contributing to the embodied carbon footprint?
We are just showing it as a negative value, meaning like that, we want to acknowledge that it's already there. So, you see basically the magnitude, but we're not taking credit for it.
We're not claiming carbon negative because we're keeping it. We're just saying that is already sunk carbon impact.
Yes. So
let's not throw it away, because then you'd have to demolish it and include all of that cost of demolition and removal.
Right, and that's why I added the demolition, step here, because you can see, if you demolish, there is impact. Of course, you can, reuse bricks, and still make use of them. And that's the other discussion too, is, at what point do you want to maintain something, or at what point you have to put more effort into maintaining it, so there's definitely a sweet spot. But in this case, it made sense to save it.
So the last thing we wanted... Oh, sorry. Go ahead.
Yeah, just one other that just came in the chart there. BOD stands for what?
Basis of design.
Got it. Thank you.
So the last thing that we were leading to is that if you used FSC certified wood, a lot of the blue bar, which is the whole sort of cavity wall behind the cladding, a lot of that would go away because, or even it could turn negative. And I'm going to talk a little bit about this on the next case study. But if you use non-FSC wood, the impacts can be still pretty bad from a carbon perspective. But if you use FSC wood, they can, the carbon equivalent can start to go way down or even negative because it's pulling carbon out of the atmosphere and it's sustainably harvested. So we just wanted to point that out. We don't have a numerical representation of that. Was there anything else you wanted to say about this, Christina?
Yeah, so I mean, basically, just wanted to reiterate, that like, you need to make sure that if you're using wood, you should use sustainably harvested wood as much as possible, because, you don't want to have negative impact. And so basically, as part of the FSC certification, it is, certified that, some of the remaining forest or the remaining wood stays in place. And I've read a study where, like, there could be a significant carbon benefit by about 1 to 2 tons of CO2 per 1,000 board foot. So I mean, like, we're not trying to tell you empirical values. These are more like, considerations, right, that, should really go into decision making. And so that's something that we just wanted to share, like thinking about a project in different ways.
Christina, I think we might want to skip the party wall one, because in the
Sure.
interest of
Yeah.
But as Christina mentioned, like, we're trying to show the big swings, right? Because it's not acceptable to do marginally less carbon intensive projects. We have to push them hard. So if we can see ways to make big differences, that's what we're focusing on. Okay, so this next project is North Negley Avenue in Pittsburgh. This is the rendering of its eventual self. But it does not include the greenhouse from the salvage windows or the regenerative farm plot in the front yard. That comes in the next phase with the synagogue rehab. In any case, we want to remember that biogenic carbon, it actually comes first in the form of trees, which keep us cool, reduce heat islands, sequester carbon, and they can eventually provide renewable materials. But we have to protect the forest from which that material comes. I did a bunch of studies here. We have a basis of design wall. It was initially a foam-free wall. However, we were forced for a number of reasons to use a rigid insulation on the inside of all this stone wall that you can see. The Hebrew school, the wing off to the left, is existing brick. The existing stone out front is going to be an open courtyard, so that's really not what we're talking about. We're talking about the 2-story brick building in the back, which also has another wing facing away from the picture plane in an L shape towards the west. In any case, this study is of the retrofit wall, and again, we have all of the cycles. We have the product manufacture, construction process, use, end of life, and eventually beyond building life, and the net total. Those are the different things shown on the chart. The blue wall is this backup frame wall, which is pretty steady and consistent throughout. But you can see the bright teal blue is polyiso-cyanurate insulation, which we were required for a couple of different reasons to use. The sheathing is the orange layer. However, we again were able to convince the team to actually save money by using reclaimed polyiso. And so you can see that you eliminate that bright teal blue bar on the top left here. In the next scenario, after the reclaimed, we decided to try to quantify the carbon impact of using wood fiber instead of polyiso. And it turns out that wood fiber in its manufacture phase, it actually has a negative carbon impact. In other words, it's been pulling carbon out of the atmosphere for 40, 50 years. And the impact of processing and producing it does not offset the sunk carbon. So it's a negative value here, the green. The net of this wall is the blue wall and the sheathing, the backup wall and the sheathing minus the green, which is the wood fiber insulation on the exterior. And that gives us this yellow bar. Now we have 2 layers of continuous insulation, one on the outside and one between the brick and the backup wall. And if we use wood fiber for both of those, you can see that our carbon footprint, our net carbon footprint, this sort of light green color here, is a dramatic reduction from the basis of design wall. So these are things we did not manage to accomplish, but we wanted to accomplish. And in fact, wall on the upper stories is it does use wood fiber insulation, so it does achieve this low embodied impact. The next phases you can see through construction and maintenance, there are increased impacts. We total all the impacts, but if you consider the impact of the, I'm sorry, these are the total impacts in this column here, E, C, C, A through C. So that's basically the embodied carbon of all the phases up through the end of life. Now, if you are able to reclaim or recycle the backup wall materials like wood, the sheathing, the wood fiber insulation, you could claim this to be carbon negative in this end of life phase. So if you were to consider these walls, this wall we're describing, the basis of design, the reclaimed polyiso, and then using biogenic wood fiber materials, both of those walls are net carbon negative, which is to say they store carbon. So this is where we want to go. We didn't quite get there on this project on the retrofit wall. However, on the new construction wall, we were able to use wood fiber insulation, and you can see that this sort of beigey green color is the wood fiber insulation. Our net carbon footprint of the material manufacturer of these walls is the yellow bar here. There's added carbon for maintenance and construction and maintenance. But then ultimately, these are our totals, okay? But if you include the circular economy we referred to earlier, the negative carbon storing potential of these materials being reclaimed gets us into the carbon negative realm. Now that's a lot of talk, and it's a lot of modeling with some pretty inexact tools. I think Christine and I were both a little surprised at how inexact and ineffective these tools could be. So we did a lot of breaking things out to say, well, Athena tells us this, but if we remove that element, what's the numerical value? Could we supplant it with something else? Athena was not flexible enough to do what we needed to do. So I would not consider Athena really that useful a tool other than as part of a process. But there are other tools like EC3, which was, you have to have so much data on the materials and the quantities of materials. You basically have to be working from a bill of sale and the total quantities to get a real number. So somewhere in between those two, there needs to be a tool that gives us some more useful values early in the design phase.
And we also want this to be, you know, for like people just making simple, easy decisions, right? Something that's simple, but you don't have to spend much time, because this is something, you know, that we're adding to our practice, but it's not, you're not being asked to do this. So it needs to also be, you know, makes sense, you know, to be like, do it fast and, you know, efficiently.
Yeah, and for years we've been doing foam-free passive houses, and we were doing it based on intuition. We were trying to use biogenic insulation materials or recycled ones like cellulose whenever possible. And that was just our gut feeling that it was the better thing to do. Now that we're doing the analysis, we're finding that that intuition is generally supported. All right.
But
so
you were making such a cool analogy yesterday. I have to share this. You were saying that, you know, you have this feel about, you know, it's almost like touching clay and, you know, knowing what it needs to be when you do art. So I think that's kind of like getting the backup of, like, you know, our intuition is a great next step for us.
Right. And so we have to use the science, we have to use the data, but we also have to use common sense. Because when I grew up on the Northeast coast near the ocean, and I saw foam washing up on the beach, I knew it was a bad thing. I saw diesel belching from trucks on I-95. I knew it was a bad thing. Like, children know this stuff is bad. So let's use our intuition and do the right thing. This is actually a good segue into this slide, which is to say our position is that design practice has to be advocacy. Asking politely is not enough. You're going to get resistance at every single phase. You need to make allies with people who think, when you think there's a window, even people who are maybe obstructing your progress, make allies with them, bring them possibilities for cost savings proactively. Provide the material and vendor contacts and follow up with them, even when they say, "Oh yeah, we priced that." Call the person. Like we are kind of unrelenting when it comes to asking our GCs who maybe are resistant, and then getting our own information and putting it on the table in front of the team. It doesn't always make us the most popular person, but on balance, it has, because people see that we're able to accomplish, in many instances, cost savings as well as carbon reductions.
And being persistent
Michael,
often pays off, of course.
And I just wanted to jump in for a couple additional questions before we do shift gears. Could you just define again for us biogen insulation?
Sure, this slide is perfect for that, actually. Biogenic insulation is anything that grows naturally. So it could be a fungus, it could be straw, it could be wood that's then processed into fiber. These are all examples. Blueprint Robotics on the left, it's Martin Lettenmeyer, their chief of operations. We've built several mock-ups with them for carbon negative walls and their passive house walls as well. We're using them on several projects. The new frameworks is building panelized straw panels. Nature Built on the right is doing the same thing with the clay plaster already installed when it's delivered. So we could do a lot of the same things we're doing. Like, this is my definition of appropriate technology. You know, doing prefab with a bunch of steel isn't an appropriate technology for a carbon crisis. Doing prefab with biogenic materials might be, right? If your transportation impact isn't too great. So we could have localized biogenic source materials and turned into panelized construction. Maybe that's the way to go. But panelization itself, or prefab itself, is really not the solution. We need it to be focused on renewable materials. So the gold standard is to use a rapid growth cycle biogenic source. So if you're growing hemp, it grows really fast, pulls carbon down aggressively. If you're growing a tree that is sustainably harvested, it sequesters carbon for 30 to 80 years, and then you cut it down. We don't have 30 to 80 years. So it's better to use a carbon storing material, but it's not, it should be regenerative materials that are a rapid growth cycle, if at all possible, in any instance. Okay, there are a couple other things we want to talk about briefly, and I know, Keegan, what is our time limit here? How much time do you think we have right now? Because we have a couple more things.
Yeah, so we're at 12:50 and the webinar is scheduled until 1:30. So.
Okay, so we're not doing too badly, but we will try to move along here. Another thing is, as Passive House people, we all got really excited about VRF systems. Turns out that Project Drawdown was the first organization that made me aware of this. Refrigerants are literally the leading cause of climate change. If you were to look at all of the ways in which you could reduce your climate impact, refrigerants would be number one. Unfortunately, this little chart on the lower left is the AIA 2030 challenge chart, or it's a international energy. I can't remember the source. I made it so small, I apologize. I can tell you if you're curious. But basically, this is the CO2 emissions per capita of all these different countries, right? You know that the one on the left, the tall one that's really, really bad, is the United States. The high world average is this arrow here. The world average is way down here, and that's because poorer countries, people living in grinding poverty, it turns out, have very low per capita carbon footprints, but their standard of life is improving. You've got millions, if not billions, of people buying new refrigerators and air conditioners. If we do everything right, but don't address refrigerants, we're still cooked. So we have to find a way out of this trap of refrigerants. We're going to show you a project in a moment. This is a wonderful project using mass timber, but this is the VRF system. That's a lot of refrigerant. Can you save the planet by using high refrigerant systems? I would posit that we cannot. And I do so respectfully and with humility, because I know there may be people a lot smarter than I am who could say, actually, on balance, you can. But I'm going to say, since we have to do everything right, we should try to eliminate refrigerant to whatever degree possible. So Massachusetts Passive House had a presentation just a week or two ago that included this hex system on the upper right. It's a Mitsubishi system. It's existing. Instead of using refrigerant, it uses a tepid temperature loop and localized heat pumps, unitized heat pumps in the apartments. And so you can do the same thing you can do with VRF with water. This Ifoca company, it's relatively new to us, but they have these through wall PTAC things, which are airtight and very efficient. And they have this VHP, which sits in a soffit, say above a kitchen, and delivers your heating, cooling, ventilation, and dehumidification for an apartment in one unit. We all have probably heard about Minutair down in the bottom right, and Sandon. Both of those. Sandon is CO2 refrigerant. Minutair has a tiny bit of refrigerant that's packaged in the unit. So basically, we have an option of choosing not just efficiency, but efficiency plus the lowest carbon footprint we can across both assemblies and systems. All right, the last thing I want to mention, and Christina, please feel free to jump in if you have anything to add to this, we're doing a bunch of projects in Washington, D.C. right down here, Barry Farm. We're completely redeveloping. We're not doing it, of course. POA is, and we're the consultant. A total neighborhood redevelopment, all to Passive House standards, all with solar and backup storage. It's pretty exciting stuff. But if you look at Washington, D.C., and imagine the plume of carbon dioxide being emitted from this city, from buildings in this city, how much of that carbon in this picture is coming from new construction? If we build every single new building to carbon negative standards, Passive House standards, net zero standards, what have we accomplished? Well, we've accomplished a lot, but not enough. You could find the good buildings on this map and there would be a tiny, tiny, tiny fraction. So deep energy retrofits are not optional. They are complicated, but they are not optional. We're going to show you several, both of those projects we showed you are deep energy retrofits. Now, if you look at these charts by Siegel and Strain Architects, they're a big part of this movement, the carbon sort of sensitive architecture movement. The chart on the left is emissions sources in millions of tons of carbon emissions equivalent. Operating emissions of new construction is this tiny little bar on the left because we make buildings pretty efficiently now. Embodied emissions of new construction is pretty low, like we're getting better. But the operating emissions of existing buildings dwarfs both of them. That tells us, if we go over to the CO2 emissions by project type, you can see that large, heavy buildings have a very large carbon footprint for construction. Small, light buildings have a moderate, but still present carbon footprint for construction. But on the right, renovations have the lowest of all. What that is telling us that our problem, the operating emissions over here on the left, is aligning perfectly with the best opportunity. So operating emissions can be dramatically reduced by the lowest carbon footprint kind of project. So this intervention is the lowest carbon footprint and it achieves the greatest result. So we cannot build our way out of climate change with sexy net zero buildings. We have to do retrofits. Now, thanks to Adam Cohen for sharing this with his integrated project delivery course. This is a chart that just shows time from left to right on the bottom and effectiveness and cost vertically on the left. The blue line is the effectiveness of change, and the green line is the cost of change. And I think we've all heard this. I apologize again for preaching to the choir, but usually the decision-making process in design build projects is backwards. Here in this green zone, we would have the greatest effect of making design changes for the lowest cost. But at some point, those lines cross and it becomes more expensive and less effective to make change. And this pink bar, whoops, is basically when we usually start doing that. And the orange is what we're doing on several projects right now, is chasing value engineering savings where it's the most expensive and the least effective to make design changes. So again, this is just the same passive house argument for integrated design teams and integrated project delivery. Okay, Christina, you want to talk a little bit now?
So these are your slides, though. I'm obviously not a white male architect, but I'm an architect. And so basically we're trying to kind of identify, what it takes to like make a difference, right? So, like how to have impact. And, oftentimes we as architects, or you maybe, Michael, as a male, you would say that you have maybe seen this, that, the architect should say, well,
since I'm a white guy over 50, I could take this one. All right.
Okay.
The Google's stock photo of a white male architect looking confident in his home office. The typical white male architect, or Greta. Okay, we know who that is. We hear from the architects all the time, and I'm not bad-mouthing architects. I'm married.
Yes, we know that. I'm one of them too.
But how often have we heard, you don't understand, my clients aren't asking for this, so I'm powerless to do anything. And my answer to that is wrong. You are not powerless. You can play a role in educating and changing the conversation. Who has more courage? The typical white male developer, not Hank Keating. He's definitely not the typical white male developer, or Greta. And we know who has more courage in this instance too. The developers that say, oh yeah, I'd be happy to do that green stuff if it fits in the budget. Meanwhile, that developer has not put anything about the cost of carbon emissions in their pro forma. So there's not only a rethinking, but also real courage required by the developer. And here's a housing agency official who, I blurred it because that actually was a real person. But I have heard people say, don't do anything more efficient because it costs more and we get less housing out of it. And I've also heard people say, please don't speak so openly about sustainability because you're going to scare people away from our RFP. Like, these are all poverty mentality and fear-based stances. Now, you could say Greta is outside of the systems that all of these individuals are embedded in, so maybe it's easier for her to have courage, but I don't think what she's doing is easy. The point is that if you put all these people together, you get incrementalism, incremental improvements, incrementally less bad projects if you're lucky and persistent. But folks, incrementalism is literally the demise of our planet and our civilization. So we all have to have serious courage, and courage doesn't have to come in big packages.
Right, and so I wanted to give a shout out to my dad. So my family is in the south of Germany, and as I said, he instilled really like an appreciation for the environment in me. And so he refuses to like ride in a car, whenever possible, or I think he hardly ever rides in a car. I mean, sometimes he does, but not very often. And so I wanted to show you guys some examples of why he's my hero. So for example, on the right, you see how he brought home the Christmas tree, on a bike. And then when my husband and I and my daughter, we arrived for a trip to Germany after, being away for so long during the pandemic, and with a broken suitcase, he took it upon himself to take to be repaired on his bike. So it looks a little bit ridiculous of how he was able to manage to strap it on his bike. But that's basically, his way of thinking and living his truth. And I think that we all have, we can have an impact, and we, all the decisions we make, they have an impact. And so I wanted to share that with you guys.
I don't have such a slide, but the house behind us, the house you see behind me, it's a 1954 energy monster ranch. We've done a deep energy retrofit. We're almost zero. And we've done it all with low carbon materials. Like, all you have to do is care and decide. Yes, it takes money, but we're paying the home equity line instead of an energy bill. It doesn't have to mean you're cash out of pocket. In any case, we say that we want to practice our design practice as advocacy, and on all of these projects we are doing so. In many instances, the team is eager to take up that mantle as well. So I think we have some slides here of, yes, 11 East Lenox Street there in Boston. This is under construction. It is a mass timber structure. It's 7 stories of apartments. The podium is mass timber. Everything is mass timber. And it's been a wonderful project. Monty French Design Studios is really great. Haycon, the builder, is great. Nordic Structures, everyone's been great. So that has been a real reward to work on.
And we also just achieved pre-certification for the project. So we definitely hit a big milestone.
Yep. And did you want to talk about this stuff, Christina?
Yes. Yeah, so basically here you see the first cross-laminated timber beam going into place. And, you know, we wanted to kind of share with you like a little bit of the sustainability story here. Of course, again, those aren't like, you know, total life cycle analysis, you know, claims, but, you know, it kind of shows a level of impact. And so when you look at this here, you know, and the volume of wood being used, you know, and you know, how much the forests grow, you know, for 3 minutes here, and then carbon stored in the wood and avoided greenhouse gas emissions, and the total potential carbon benefit as compared to non-wood structures is significant. And when you think about it, like the equivalency here, like 247 cars off the road, that's a big impact. You know, my dad is saving 1 car off the road, but, you know, this is huge. And then also, you know, how much energy to operate the homes here is being saved. So, you know, like just, you know, thinking about smart choices, you know, that have big impact. I think that's a big story we wanted to share with you guys, especially on a local level.
And Christina, you know, you pointed out this is not a whole building assessment. We didn't do an analysis of the ready core concrete stair towers. We did not do an analysis of the cladding system. We assume that everyone in every part of the industry is going to have to be aggressively evaluating what they have control over. We don't have control over many of those decisions. We advocate for what well, even outside of our lane, we advocate, but definitely we advocate for things inside our lane. We don't want to take too much credit on these projects because this team was already way ahead. Haycon Construction, Boston Real Estate Collaborative, Monty French Design Studios, BLW Engineers, H&O Structural, everyone was on board. So we're now we're just delivering the model results for a 12-story hotel, which will also be mass timber. It'll be a low carbon envelope passive house. We also believe we can do this with low carbon systems as we described earlier. We've just begun working with the Smithsonian Institute on a village of housing. They will not look like those little cottages, but that's the rendering we were given. And then ultimately, we'll be building a lodge here for housing of scientists coming to do environmental research down here in Maryland. So that's an exciting project. We hope to have that be a carbon negative project with a resiliency microgrid. This is a great team, Somerset Development, Eric Colbert and Associates Architects. Stengel Engineering is on this one. They're also on the 1600 on North Ave Workforce Housing Project. This is a CLT podium building, the first of 2 phases. The second phase is a 7-story mass timber tower. And this is Barry Farm. POA from up in your neck of the woods is redeveloping this. Julie Klump has been just a fantastic person to work with, as Deanna Savage. And so this entire neighborhood of 1,100 residential units and 55,000 square feet of retail space will be passive house. So we just wanted to conclude with that to say we have all of the solutions that we need to achieve carbon drawdown and restore the balance in the climate and in the level of toxicity we pump into the world. So we have all the solutions. We just have to choose them. And I guess this is our invitation to please do anything you can and join with us and educate us with your successes on how we can accomplish these goals. It's not scary. It's really fun once you get into it. And so be radical, push harder than you think you can. It's not really a risk. We've never lost a job because of this. We know how to compromise, but lean in. It's fun. Christina, anything else you wanted to say?
Yes, I wanted to just like make sure to thank everyone, and we want to just like, you know, like end on a really, really positive note. Everybody, you have, you know, you can make an impact, you have a choice, and, you know, I think, you know, we want you to join us in this movement to leave the world a better place for future generations.
Thank you very much. And I can stop sharing now, I think, and perhaps we can take questions.
Yeah, thanks, Michael and Christina. This is Keegan, and I can go back on camera here. So we had a number of questions come in, and I do just want to remind all our participants again that today's presentation was brought to you by a partnership between Energize Connecticut and Mass Save. So there were a couple questions around the software that you guys use to do some of your calculations, and a few people asked if Tally was utilized. So I wanted to put that to you both.
So, you know, I'm an architect, so I have used Tally on projects, but as a passive house consultancy, we don't really use Revit. So, you know, like that's why we, you know, we didn't use Tally. But I mean, Tally is a great tool. So, and it would have probably made our life much easier, I think, if we could have. But, you know, like, you know, that's basically our plea for simple tools, you know, that, you know, maybe anyone could have access to. I think that's what we would like to see. But yeah, Tally wasn't used, one of them. We used Athena, and we also looked at EPDs, you know, like made some inferments. We also looked at EC3, but, you know, so like, I think we're just trying to have an open mind that, you know, looking at all these different tools and see what we can learn from them.
Within EC3, we were able to find data that we could then, through spreadsheets, sort of reverse engineer the results of Athena. And so it's not probably the most scientifically validated process. But again, you know, as Christina said, we pay for any number of different modeling tools to do passive house. We're not a big company. We couldn't just go and get Revit to do this. And yeah, it really should be something that anyone could do. It could be available to any designer. You shouldn't have to have a total BIM model. Now there are people, like we ended up building some of our own spreadsheets, right? So, but Athena had all these assumptions built in, and we had to question them, and we can't question them enough to know for sure what's going on. So we did experiments, right? Christina, you spent a lot of time breaking things out, bringing other things in.
Right, so we're using, you know, the tools to our advantage in a way that makes sense to us, I guess, you know, so that.
And that would be one more opportunity to emphasize the fact that this is not about, oh, could we shave 10% off here or 15% off there and say we're doing something green. This is about, if it's not a wholesale reduction, we're not particularly interested. So maybe a cruder tool that shows larger swings without the absolute accuracy is okay with us. But we certainly, I'm sure plenty of people in the audience have probably done as much or more than we have.
Right.
Hank Keating invited us to do this presentation at the time. I thought, well, Hank, we're not experts. You know, we're evangelists maybe, but we're not necessarily experts. And but he said, well, I'd like you to do it. So we said, all right, we're going to buckle down and do this. No one's paying us to do it. So that's another reason we don't go out and invest in, you know, the expensive tool.
Right.
So.
Right.
Great, thank you. Yeah. Another question here, can you discuss any other sustainable forest certifications other than FSC, and have there been studies comparing them based on the carbon impact?
Yeah, so what is it, Sustainable Forestry Initiative, SFI, I think it's called. That is an industry group, it's not a third-party group, and my understanding is it's still pretty awful. So I actually have gone to like the local big box lumber yard and asked for, you know, sustainably harvested timber, and they'll say, oh yeah, it all is. But if it's SFI, which most of that is, it's not. Now, there is a book. I don't think I have it within reach, but it's called The New Carbon Architecture by Bruce King. Oh, I do have it within reach. This book has some great charts. And one of them shows the carbon footprint of non-sustainably harvested wood versus concrete and steel. And it's really not much better. But sustainably harvested wood is a powerful carbon sink. There are another issue is that there are plenty of local woodlots that can't afford the FSC certification. So being local and knowing your providers may be as good a solution as FSC. I don't know of any others particularly. Do you, Christina?
No, I think that the main ones that I'm also familiar with. Mm-hmm. But yeah, maybe if people know other resources, they could put it in the chat and we could share it with us, Keegan. So that would be
that'd be great.
Yeah, absolutely. So this one I think was maybe specific to one of the project examples you were showing. But what kind of rating was needed for the exterior wall assembly, and were there any code issues in using wood fiber as an insulation material?
We didn't come up against anything. That was a 4-story building. So I think those were just 1-hour assemblies above the retrofit. So I don't think there was anything particularly challenging about that. I think one reason, Christina alluded to the 2x8 wall we're doing with no continuous insulation. And we've done that in Beverly, Massachusetts, Guilford Village in New Hampshire. We've done it in DC. We're doing it in several places in DC. This is no continuous insulation wall. It's just blown in cellulose. And by compensating elsewhere and being clever about certain things, we're able to get buildings from climate zone 5, borderline climate 6, all the way down here in the mid-Atlantic to be passive house without any exterior insulation. That would allow you to do a different rating on the wall with no foam, right? And also, it should be said, you can get a fire rating on a wall with foam insulation, but how do they do that? With flame retardants, which are like appallingly bad for the environment. People, don't use this shit if you can avoid it, excuse me. Don't use it if you can avoid it.
Yeah, me too.
Yeah, great, thank you. Yeah, we had someone asking, Michael, for you to clarify your comments around the impact refrigerants have in terms of affecting climate change and greenhouse gas emissions.
Yeah, I have to get another book down. Drawdown is this book edited by Paul Hawken. He's a good author and has written other books, but this is, he edits it and scientists have contributed. And he signed it for me. That's for my wife and I. That's nice. Super good book. And he's now left Drawdown and gone on to write a book about being regenerative. He's got charts and graphs in here, the scientists do, that have backed them up on all of these things. And I would have to look through here and find the refrigerant page. But it was, some refrigerants just are vastly worse than carbon dioxide, right? And some are moderately worse. So if maybe by the time we're finished, I can look up in the index and tell you like a number, like an average or a range of impacts. But refrigerants, like we did VRF system on Weinberg Commons, which is a deep energy retrofit in Washington, DC, brick and block projects. Basically, we wrapped them. I didn't put it in this presentation because we were talking about other stuff, but it was our first multifamily project and it was a deep energy retrofit. It was really tricky. And we have VRF system because basically the MEP, well, that's all really that makes sense. Well, within a couple of months of occupancy, there's a lightning strike and all of the refrigerant was released. And I'm wondering if we undid our carbon benefit in one split second of a lightning strike. And so maybe I'll take a moment if anyone has a question for Christine and see if I can find it in the index here. But the answer is refrigerants bad generally, and they're getting better. but they're not good enough. Like if we have to do regenerative, remember, we have to stop doing less bad. We have to start doing good. So we have to like zero out anything we can't make regenerative. And refrigerant is one of those things. So dramatic reductions is important.
Yeah, so another one here I think is a good one around wood and biogenic materials as negative impact on these projects might create sort of an adverse incentive to use perhaps more than needed to zero out the carbon footprint. So thinking about the comparative impact of using wood versus letting wood or other materials versus letting those continue to grow and continue to be carbon sinks.
Right. Yeah.
Yeah.
And that, I mean, that's, what would we say, Christina, to that? Like, we don't actually know the answer to that. But that's why this notion of reduction of all things, conservation first, is always your first step, right? So for example, passive design. Like, you don't have to put a west wall of glass that requires cooling, or, you know, non-productive wall of glass that requires heating. So you don't want to have as much insulation. I don't care how good the insulation is, you don't want more of it if you can avoid it, right? Hit your comfort criteria, hit your resiliency criteria. But right, you see, you know, like around here, all of a sudden everyone was crazy about wood pellets and corn stoves and stuff. And, you know, so they're tearing down forest in the Southeast to provide wood pellets. I mean, that's obviously nuts, but people are calling it a sustainable option, right? So I'm very sympathetic to the questioner. I will say that if what Nordic Structures says is true in their product summary, and they have an enormous amount of forest under their control, which they harvest sustainably, and that forest is growing, you know, in a handful of minutes, right, is pulling down enough carbon and providing enough material for these buildings, then I think we could do a lot of reforestation and still build a lot of buildings. But you can't just build everything out of mass timber all of a sudden. Maybe we need, again, this is an argument again for retrofit, right? We can't, like, we got a whole city just over here, a couple miles away in Baltimore, 16% vacancy, and they're still building massive multifamily crap developments all around us. We gotta stop doing bad things anywhere we can.
And so
that's not really the question, but.
And so where I come from in Germany, it's densely populated. There is no even land, you know, to grow all these big forests, you know. So, you know, you obviously have to be considerate about what you're putting in your materials, you know, just to begin with, you know. And so, yeah, it's not like just like throwing something that's green or, you know, sustainable onto something, you know. You have to be considerate about how much you actually should use.
Yeah, so I will say one other thing I would just drop into that is, yeah, we have found that we can get lower carbon net buildings by not hitting passive house sometimes. Like if you're having a hard time, you know, we only do passive house, so I'm not advocating against it, and I'm certainly not advocating against certifying. I totally believe in it, right? But there have been some projects that are retrofits. Just working one yesterday, we just couldn't get there because the slab was already in place. We couldn't go above it because of head height issues. Like it wasn't going to hit passive house by a narrow margin, but it wasn't going to hit it. But we were able to look at material selections and say, well, look, we're getting a net carbon benefit by using this particular material. So we don't actually have to hit passive house in this instance. It's already net positive.
Right, so this holistic approach is important.
And that segues into another good question. I think we've got time for a couple more if you guys are good to hang on for a few more minutes. Around, are there resources that you can suggest for determining the carbon content of commonly used materials, so folks can you know, review and make these evaluations on their own? Okay,
so Christina, you may want to speak to this, having done living building.
Right, so there's a website, you know, environmental declaration website. I just, you know, I don't know exactly what the acronym is, but, you know, like any environmental EPD is like listed there and it's like a global thing. So, you know, you might also find things in Australia or Germany or whatever. So, you know, you have to take it with a grain of salt. But there you can look up at, you know, all the different life cycles too, you know, global warming impact. I just wish I knew, I think it's environdeck.com, but, you know, I don't want to lie. So I would have to look it up real quick too. But, you know, I mean, if you search it, it's basically has like a repository of all this information. And then EC3 is a nice tool that, you know, definitely is something you could look into. And then again, what we use is Athena, but it has all these assumptions baked in. So we don't have impact on what, you know, what assumptions are there. So, you know, that's why we were doing our own inference sometimes to like, you know, make informed decisions.
So the Carbon Leadership Forum is a good resource. There's a lot of people talking about releasing papers and alerting each other to the papers they're writing, studies they're doing. Carbon Leadership Forum is great. And then through Carbon Leadership Forum, we, you know, learned about EC3 a little while ago by trying to watch tutorials and figure out how to use it. You know, there are also tutorials on how to interface with the EPD providers. And there's one organization in particular, and again, the name escapes me, I'm sorry, maybe we can send it out via email. But there are, basically, once you start doing your research, you're gonna come across these things. But I think it's fair to say, within EC3 itself, there are 1,600 products, but a lot of them are cladding and finishes and not necessarily the things we need. There's a lot on concrete. And I'll have to look back at it to see what they have on sustainably harvested timber. I did find one sustainable timber company in the Northwest that had hugely negative carbon numbers. It's really, and then there are some European organizations that you'll find things on like Styco or Gutex Insulation. They have, there's actually a whole set of organizations. There are rule-making organizations for how they actually get structured. So we're just honestly dipping our toes into it. We were using readily available resources.
Yeah, not every document that you can find is also certified, you know, so you have to like also take it with a grain of salt, of course, you know, everything needs to be kind of double checked.
Yeah.
Sure. And specific to, you mentioned a project that was using reclaimed rigid foam board. Are there resources available for folks if they wanted to look into that path, or?
You can, you know, honestly, the Borg, I mean, Google is maybe one of the better, you know, is a fine resource. Like we found a company there in Boston called, I think it was like Green Insulation Solutions. Boy, I wish we'd come prepared with a list of these things. But there are a number of different providers across the Northeast and the middle, and then in through Pennsylvania and up the Midwest that are doing reclaimed foam insulations. And it's funny because initially we were, you know, we'd call them and they'd say, "Oh yeah, we got a truckload coming in. We'd get you something." And then as soon as the mineral wool people were having trouble with supply chain issues, and wood fiber people were having trouble with supply chain issues, it started to hit that little sector of the industry as well. But I think you can do a fairly limited amount of searching and start finding things online.
Yeah, and we've also used reclaimed XPS, for example. So I worked on a project where, you know, like our structural engineer, for example, deemed it not feasible to put it under a slab. They just didn't trust, you know, the structural capabilities. But, you know, there are so many applications where that doesn't matter and where you can actually use it.
Yeah, and someone shared with us in the chat the website for greeninsulationgroup.com that you mentioned.
That's right. Ron Gluck is the guy, and he's been really great. He's provided us reclaimed foam and a whole bunch of stuff. So, yeah, look around. You'll find it.
Great. So I think we have time for one more question. And this one was specific to the project, the Large Passive House project in DC that you shared at the end. What kind of heating system was planned for use in that project?
Heating system? The one that's under construction is VRF. I think we still have time to consider alternatives on the subsequent 2 large multifamily buildings. I, like most people, learn each time. And I've always been suspicious of VRF, but until I read this book, I had no idea just how bad refrigerants are. Now, a lot, obviously, because of the ozone depleting, the awareness of ozone depleting characteristics of this stuff, like these have been improving, but their climate change impact, I think, was not fully appreciated largely, and it still isn't. So you're not going to be able to convince me to just default to VRF anymore, ever. Like, I'm going to be trying, we are going to be trying, I should say, at every opportunity to do something else. There are times when it's a relatively small compact system when it might do well for a small institutional project without a ton of refrigerant runs, but pretty much there's a go-to solution for a number of years. Once you're in a passive house, in the room with passive house people, it's like, okay, we got to use the most efficient thing. It's not, efficiency should not triumph over carbon sanity, but we're learning new things. So little did we know.
That's great. Yeah, thank you. Well, we're at 1:28. So if you guys have any closing thoughts or anything, I think we can call it a wrap.
Well, all I would say is, look, we offer this with a lot of humility because, as I said, when Hank said, hey, can you give this presentation? We don't consider ourselves experts. We consider ourselves motivated. And Christina and I just spend some evenings kind of staring at things and our eyes crossing and saying, oh my gosh, how are we going to figure this out? Like, we all just have to care. Like, and we cannot accept, oh, we're a part of a system and this, the developer or the architect says, no, the developer doesn't want it. Well, if you get through the architect to the developer and the developer says, oh, no, it's not, it doesn't, make sense. But it's really, but you get through to them and they say, oh, we want to do it. Well, the financing organization, are they bought in? Like, there's so many layers in this system. Everyone in every part of the system has to be taking a proactive role. And so we're just trying to do our little part.
Right, and it's really about advocacy, like sharing your knowledge, learning from others, and trying to make a difference.
Thanks, guys. Yeah, and we've got a couple folks asking if there'll be a recording of this available to review or to share with others that weren't able to make it. Anna, do you want to chime in and let people know where they can eventually find that?
Yes. We will be sending this to CTPH, Connecticut Passive House, and Passive House Mass, and they will be uploading a recording onto their site. So we will send out an email to everyone, letting everyone know when those will be up on the sites to view.
Great, thank you. All right, well, Michael and Christina, thanks so much for the presentation today. Take care.
Thanks so much.
Appreciate it.
Thank you.